Hey there, I'm Jill, and this is my first ever video blog. Today's video, I'm going to teach you how Prim's algorithm works, and I'll also provide a graph to properly show you how to get Prim's minimum spanning tree. So get along with me, and let's get started. Prim's spanning tree algorithm is one of the methods used to find the minimum cost spanning tree. Similar with Kruskal's algorithm that does not have any cycle. It uses the greedy approach with the shortest path first algorithms. It is an algorithm that takes a graph as input and finds the subset of the edges of that graph, which form a tree that includes every vertex, has the minimum sum of weights among all the trees that can be formed from the graph. Now, what is a minimum spanning tree? A minimum spanning tree is the spanning tree where the cost is minimum among all the spanning trees. The cost of the spanning tree is the sum of the weights of all the edges in the tree. So this is how a spanning tree looks like. It is represented with vertices, along with edges, and their weights. Now, let's do it in Prim's algorithm. Initialize the minimum spanning tree with a vertex chosen at random. Find all the edges that connect the tree to new vertices. Find the minimum and add it to the tree. Keep repeating step 2 until we get a minimum spanning tree. We'll start by choosing 1 as our arbitrarily node. In this case, vertex 1 is visited. After choosing the root node, you can see the adjacent edges are 1 to 4, 1 to 3, and 1 to 2. Now, examine the vertices reachable from 1 to determine which edges has the smallest weight. In this case, 1 to 2 is lesser than the others. We mark them red as the start of our minimum spanning tree. 2 is now added to the visited list. Now, look at all the nodes reachable from 1 and 2 have a weight of 3. I have chosen vertex 3. 3 is now added to the list. Vertices reachable from 3 is 4, 6, and 5. Obviously, edge 1 is the last weight. Pick 1 and add 5 to the visited node. We'll just continue in this process, each time choosing the smallest edge that connects to an unvisited node. As you noticed, node reachable from 2, which is 5, have a weight of 3. But since we follow MST properties, which is one that does not create a cycle, and both vertices are already in the MST, so we do not pick it. Instead, we proceed to other adjacent edges and nodes reachable from 3. In this case, we pick 6, since it has the least weight. The unvisited node remaining is 7, so we add 7 to the MST. Finally, all the vertices are connected in a tree. Lastly, you add the edge weights to get the minimum spanning tree's total edge weight, which are 1, 2, 3, 3, 6, 9. Add this equals 24. 24 is our total edge weight for our final MTS. That is it all you guys for Prim's algorithm. Thanks for watching and see you soon on my next video.